Okay, so then we get into the solving trig equations, which we kind of done a little bit of that because we had to set up trig equations to solve triangles. But this is just more general than that. Solve trig equations. And remember, after the lesson, then there's a quiz, because today is 5:31, last day of May. So, solving trig equations, right? The variable is always inside of a trig function, right? And so you can't solve it. You got to isolate the variable, but you can't divide by sin or cos or tan. So you've got to use inverse functions. We're going to try to isolate the trig function first, and then we'll use inverse to get at it. If it says exactly, right, that means it's going to be some answer like pi over 6, something like that. You don't just turn it into a decimal. And there are times when, when we find one answer, because we know actually that you would get the same angle by adding or subtracting 2 pi or adding or subtracting 360, you've got to take into account that there could be multiple, infinite answers when it comes to periodic functions. And sometimes they do, sometimes they don't. You'll see the difference. So solve exactly. Right, so we have to solve for the x, which is inside of that sine function. So first step is we got to isolate sine x. So what do we have to do to isolate sine x? Add the square root of 3. Now we've got 2 sine x equals the square root of 3. Divide by 2. And sine x equals the square root of 3 over 2. And I should have had, see if I still got this up here. No. Algebra 2. Open up the unit circle again. So where does the sine equal positive square root of 3 over 2? Remember, sine is the y coordinate. So you could say it's here, right? And that would make the answer pi over 3, but it's also here at 2 pi over 3. And in fact, if it's at pi over 3, if I add 2 pi, I would be back at the same place, so that would have to solve it too. And I could keep doing that infinitely. I would keep getting back to the same place. So usually the way you write the answer, because it's periodic and they didn't say not to, is you got to do this. We have to say x equals pi over 3 plus n times 2 pi. Meaning multiples of 2 pi plus or minus will get you to the same place. N is an integer. And we would have to do the other one too, right? Because there was also 2 pi over 3. 2 pi over 3 plus n times 2 pi. Did I do that? Yeah. So we'll see on a future problem here, and one of the ones that's coming, that sometimes they say only the answer is between 0 and 2 pi. Okay, if that's the case, then you can just say pi over 3, comma 2 pi over 3 and be done with it. But if they don't say that, then you got to take into account that it could actually be infinitely many solutions, and you got to add that plus n 2 pi, or if you want to say 2n pi or 2 pi n, it doesn't matter. One way or the other, you got to have that part in there. So try to do that one. Same way. Isolate the sine, and then use the unit circle to figure out what angle are you at. And make sure to include that last plus n times 2 pi. Isolate sine x. Subtract 4. And divide by 2. Right? So sine x is a half. I said exactly, so it means this is going to be one of our unit circle coordinates. You should be able to look on the unit circle and find where does sine, the y coordinate, equal positive 1/2. Here and here. So that's pi over 6, 5 pi over 6. And then because it's periodic, I'm going to have to add that plus 2 pi times n. I mean, it could actually be minus 2 pi times n too. As I said, it's an integer, not necessarily a natural number. So we got to go like this. X equals pi over 6 plus n times 2 pi. And x equals 5 pi over 6 plus n times 2 pi. So for all the trig functions, is it always going to be every 2 pi that it repeats itself? And the answer is no. Tangent and cotangent repeat every pi, not every 2 pi. If we go back and remember the graphs of those, we didn't do much with the graphs. But if this was a tangent, we'd have to say plus n pi, not n times 2 pi. So here's the other way these questions get asked, right? And that is solve in an interval, meaning we don't want x to be anything. We want to just take into account that one time around the circle. So we won't have to add a plus n times 2 pi. We just want how many are in between 0 and 2 pi. Right? This one is a tangent. So how do I isolate the tangent? Right, so it's going to be subtract the 2 is going to give us 9 times tan squared x equals 1. Tan squared x equals 1/9. And then how do I turn a tan squared into a tan? Got to take the square root, right? And when you take the square root, right, you're going to get tan x equals plus or minus 1/3. So I don't think I said exactly, but I should have said exactly on here. Solve exactly. Or actually, this one, no. No, this is not a solve exactly. I just cross it out. Cross it out. Okay, so that means either tan x equals 1/3 or tan x equals negative 1/3. And it's not a unit circle. If it was the square root of 3, that would have been a different thing, but it's not a square root of 3. So then how do I find the angle at which tangent equals 1/3? You can have to do tan inverse in the calculator, okay? What mode do you need to be in? When you see that the domain has been given in radians, it needs to be in radians, okay? So since it's 0 to 2 pi, we need to have it in radian mode. Okay. So let's try the tan x equals 1/3. Okay, first let me check my mode. My mode is on degrees, so I need to change that to radians, right? And I'll go back to the main screen. Second, tan inverse, and I'll put in 1 divided by 3. And in radians, it's 0.3218. I don't know, we could probably round off a little. Let's make it 2 decimal places, 0.32. So x equals 0.32. So just looking at the unit circle, right? Right, 0 is here, pi over 2 is here, pi is here, and 3 pi over 2 is there. So in radians, actually I should make the bottom one as negative pi over 2. No, it said in between 0 and 2 pi. So, okay, what is the value of pi? 3.14, right? And pi over 2 would be half of that, right? That would be 1.57. And halfway in 2 pi is here, that's 6.28. And 3 pi over 2 would be halfway between pi and 2 pi, which is 4.71, I believe. So which quadrant would we be in if x is 0.32? Yeah, you got it. You're going to say it's right about there. It's actually closer to the x-axis, but let's say that that's 0.32. Now, we did this already. We were doing the inverses. If tangent equals 0.32 there, where else in between 0 and 2 pi does it equal 0.32? You got to add. We were in degrees then. We added 180, but now we got to add pi to go all the way around to that quadrant there. So we would also have the same value down there. So I also have to say x equals 0.32 plus pi, which is 3.14, so 3.46. So there's two answers that come from tan x equals 1/3. Now we got to repeat the process with tan x equals negative 1/3, right? So second tan inverse negative 1 divided by 3. Negative 0.32. That makes sense. So again, if I'm looking at that, negative 0.32 would be in which quadrant? What does the negative tell you to do? You're going clockwise around the circle, right? So if 0.32 was here, negative 0.32 would be about right there. Now, is negative 0.32 one of our answers? Remember, it said the answers have to be between 0 and 2 pi. So negative 0.32 isn't in that interval, right? So how am I going to find the angle that's right across from it? Right there. Add pi, right? So that angle there is going to be negative 0.32 plus pi, which is 3.148482, 2.82. So if that's 2.82, I still need another answer, right? I'm still going to have to add pi to go one more time around to here. You know, that angle is fine. That negative 0.32, it's fine. It's just not in the right interval. How do I make a coterminal angle that is between 0 and 2 pi? You know, from here, negative 0.32, add 2 pi. You know, if we already added 1 times pi, now we're going to add another times pi, right? So there's one answer. And if I go negative 0.32 plus 2 pi, which is 6.28, right? That's 6.28 minus 0.32. So it is 5.96. So these two are angles that are in between 0 and 2 pi. So we have 4 answers here. 1, 2, 3, 4. Okay. So try to do the same thing with that one. Right, she all got to that point. Right, and then what do you do with that? How do you make a sine squared into a sine? Take the square root of both sides, right? What are you going to get if you take the square root of 3/4? The square root of 3 over 2. Okay, well that's familiar, right? Root 3 over 2, and it's plus or minus. So we're going to get sine equals plus or minus the square root of 3 over 2. Then you got to be thinking, this is an exact one. This is clearly unit circle coordinate. what angles in between 0 and 2 pi does sine equal positive square root of 3 over 2 or negative square root of 3 over 2? Erase these. So where are all the angles? About here, positive square root of 3 over 2. Here, negative square root of 3 over 2 is here. And negative square root of 3 over 2 is here. 4 answers. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Is it every multiple of pi over 3? Not really, because you don't have pi. That's 3 pi over 3. And you don't have 2 pi. That's all the rest of them. Okay, so 1, 2, 4, 5. So x equals pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And do I need to add plus n times 2 pi? No, because we got a domain here. It says just in between 0 and 2 pi. And why does it have like a square bracket on one side and a round bracket on the other? It means that, 0 and 2 pi are the same place, right? You would include the answer. If the answer was the angle of 0, you would include it. But you wouldn't also put in 2 pi, because 2 pi is actually not in the interval. That's like an open circle on 2 pi. Okay. Okay, so the water depth D for the Bay of Fundy can be modeled by this equation, where D is measured in feet, T is measured in time, T equals 0 is midnight. At what time is the water depth 7 feet? What are we expected to do with that 7? Plug it in for D. It's a depth, right? So we're going to plug that 7 in right there. So here's the equation we're going to try to solve. 7 equals negative 28 cosine of pi over 6.2 times t plus 35. So at this point, it's a solve an equation. Isolate the cosine, do inverse of some kind. How do I isolate this cosine? Subtract the 35. That would be a good place to start. Subtract 35, I get negative 28 equals negative 28 times the cosine of pi over 6.2 times t. And then, when you divide by this negative 28, since it's on both sides, it's almost too easy, right? Now we've got the cosine of pi over 6.2 t equals 1. Okay, so how do I get to the variable which is inside the cosine function at this point? I got to do the cosine inverse. I mean, don't worry about the pi over 6.2 part of it. All of that is inside the cosine. So how do I get rid of the cosine? I take the cosine inverse of both sides. Okay, when I do that, I'm still going to have pi over 6.2 times t. But where is the cosine? At what angle does the cosine equal 1? At 0, right? On the unit, that's a unit circle coordinate. I mean, cosine is the x, it's here. So it's either 0 or 2 pi, and actually it just keep going on forever. And I think if you read the problem again, I mean, the water depth obviously goes up and down forever. So in fact, we can say 0, right? 0 plus n times 2 pi, which is n times 2 pi. Okay, but we still haven't solved. What did I do with my extender? We still haven't solved for the t. How am I going to solve for t since it's being multiplied by pi over 6.2? Multiply by 6.2 over pi, you know? So I was trying to move this down, but I don't see, where's the page extender? It says it's there, but I don't see it. Okay, so I'll just do it over the side here. So t is going to equal 6.2 over pi times n times 2 pi. Oh, I didn't put the n in there. Okay, now the pi's cancel. And I get 2 times 6.2, which is 12.4 times n. So their question is, at what time would that be? 12.4. 0 is midnight, so 12.4 ought to be 1224. Multiply times 6 or 60. Right, so it's about 12 o'clock noon, and then because of that n right there, it's going to repeat itself every 12.4. So I'll say that's 1224 in multiples of. Okay, I don't even know where the Bay of Fundy is. Does anybody know the Bay of Fundy? You can study that in some class. Okay, solve. So this is kind of like when you move from solving linear equations to polynomials. You know, you can't isolate anymore. You can't isolate the sine function anymore because it's in two different terms. Just like with polynomials, you can't isolate the x because the x could be in many different terms. So instead, what do we try to do? Factor. See if you could factor it into a bunch of factors multiplied together to equal 0. If you can, then you use zero product property. I mean, are there any common factors between those two terms? Sine x. So definitely you factor out a sine x. And that leaves us with sine squared x minus 4 equals 0. Okay, so zero product property would say that either sine x equals 0 or sine squared x minus 4 equals 0. Okay, so where does sine equal 0? At 0, right? Sine equals 0 at 0 and pi, and then every time you go back, you know, to 2 pi and 3 pi and 4 pi and 5 pi, it's always 0, right? So it's actually not plus n times 2 pi. It could just be n times pi. Okay, so that one will go x equals n times pi. Okay, this one we would have to do this. We'd have to say sine squared x. Let me get that out of there. Sine squared x equals 4. That means that the sine of x is plus or minus 2. So when does the sine x equal plus or minus 2? Well, what's the range of the sine function? -1 to 1. I mean, just look at the unit circle, right? We started at 0, we go to 1, we go to 0, we go to -1, and we just keep repeating ourselves. It's always between -1 and 1. Or if you think of the graph, right? The graph looked like this, with -1 down here, +1 is here, and the graph just went up and down and up and down, right? But it can't be equal to a number bigger than 1 or less than -1, unless you multiply by something in front. So this one is no solution. So the answer is that. And just like with polynomials, if you get to this step and it was polynomials, the last thing you want to do is like divide out the x, or in this case, divide out the sine x, because you'd be losing one of your answers. In this case, you would have lost your only answer. So instead of dividing out, you factor. So try to solve that one. It's a similar kind of problem. So we should have got to that point, right? Either sine x is 0 or sine x equals plus or minus 1. Okay, well, where are all the angles that happens? Okay, sine is 0, like we saw in the last problem, at 0 and pi and 2 pi and 3 pi, etc., forever. And where does sine equal 1 and negative 1? Pi over 2 and 3 pi over 2. So in fact, this is like every pi over 2, right? 0, pi over 2, pi, 3 pi over 2, 2 pi, and just keep going. Every multiple of pi over 2, you're back to a place where one or the other of those is satisfied. So the answer is x equals n times pi over 2. Okay, and then the last kind of problem we'll look at, this again is something that if it was a polynomial, it would be a quadratic, right? There's no common factors in all three of those terms. But a lot of times with polynomials, there's not either, but we still figure out a way to factor, right? So you got to look at this not like it's a quadratic polynomial, but it's still a quadratic type, right? You could look at it like x squared minus 5x plus 2. If you had an equation like that, then you'd have to think of, okay, well, how could I solve that? Is it factorable? No. Are there factors of 2 that add up to negative 5? No. So it's not factorable. So what do you have to use then? Can't use quadratic formula, right? So in this case, if I went through the whole thing like this, right, I'll go negative b, right? Positive 5 plus or minus the square root of negative 5 squared, which is 25, minus 4 times 1 times 2, divided by 2 times 1. The quadratic formula looks the same. It just that doesn't equal x. That equals the cosine of x. So I need to simplify this, right? Cosine x equals 5 plus or minus 25 minus 8. So that's going to be the square root of 17 over 2. And now we really do need to have the decimal values of these things. So let me do that. I hate it when it does that. That's not going to work. Is that going to work? That'll work. Okay, turn it on. So 5 plus the square root of 17. Enter. Divided by 2. So 4.56. Okay, do it again, this time with the minus. Right? 5 minus the square root of is 17. Enter. Divided by 2. 4.38, I'll call it 0.44, just to round to 2 decimal places. So cosine equals 0.44. Okay, now we got to do cosine inverse on both of those. Right, for the 4.56. Second, cosine inverse 4.56. Ooh. Oh, that's right. So I got an error. Why did I get an error? Cosine can't be more than 1, so this is no solution. Even better. Okay, and then we'll go to the other one, and let me try this again. Quit. Uno. Second, cosine inverse 0.44. 1.16. Okay, well, let's see. We know cosine is 1.16. X equals 1.6 in radians. You know, that's in between 0 and pi over 2, which is 1.57. It's probably closer about right there, 1.16. But it said it answers only in between 0 and pi. Okay, so we got that one. Do we have any others? I mean, if I drop down here, right, I would get another value of cosine right there. But that's not between 0 and pi. So the only answer is 1.16. Done. Okay, let's see, last one. Solve in the interval. Okay. So this is where this can, you know, you wouldn't know to do this other than you got to see it. That's why I'm showing it to you. But at this point, you know, if you're going to isolate a trig function, actually this is easier than I thought. We got to isolate the trig function, but there's 2 different trig functions. So we got to figure out a way. How can I? Oh no, it's not what I thought. I mean, it's a sine and a cosine. Somehow I've got to make this into one kind of function. Again, you wouldn't think of this necessarily, but if I square both sides like that, you know, I'm going to get a 1 plus cosine. I have to FOIL that. But I'll get a 1 plus 2 cosine plus cosine squared. And on the right, I'm going to get a sine squared. I still got 2 trig functions, right? But I've got a substitution that takes me from sine squared to cosine squared, right? I don't have a substitution that takes me from sine to cosine, but the squares, you've got, right? So that's why we have to do it like that. We're going to go, this is 1 plus 2 cosine x plus cosine x, cosine squared x equals sine squared x, right? But by the Pythagorean identity, what does sine squared equal? How about 1 minus cosine squared? So this looks like it's going to be a quadratic in cosine. I need to get everything on one side, 0 on the other. So if I add cosine squared x to both sides, I'm going to get 2 cosine squared x. Right? I've already got a plus 2 cosine x. And then if I subtract 1 from both sides, they cancel. So that's everything on one side, 0 on the other. Then what? Factor out the cosine. Factor out 2 cosine x, the greatest common factor. So either 2 cosine x equals 0, which means x equals, at what angle does the cosine equal 0? Look at the unit circle. Where is the x-coordinate equal to 0? Here, pi over 2 and 3 pi over 2. Right? And since this one didn't ask, it said in between 0 and 2 pi, that's all we've got to do. So this is pi over 2, 3 pi over 2. Okay, and now we've got to set cosine x minus 1 equal to 0, which means cosine equals 1. Where does cosine equal 1? How about 0 and 2 pi? So x equals 0, but it's also plus, well, no, it said 0. This gave us a domain. They don't want us to go plus n times 2 pi. In fact, we don't even include the 2 pi because that's round parentheses, means 2 pi is not in there. So the answers are these right here. Okay. That's just a small taste of solving trig equations. That is homework.